solve this quadratic inequality. So the first thing I need to do when I'm solving a quadratic inequality is I need to get everything over to one side and make the other side 0. So this is going to become x squared minus 6x plus 4 is greater than 0. Now it's a quadratic, and a quadratic is a parabola. So if it's greater than 0, it means that the value of this expression has to be greater than 0. So if it's a parabola that is, say for example, opening up and crosses the x-axis and has two roots, the values that are greater than 0 are these values right here. These values of x. So all the values of x from this root that way will produce a y that is greater than 0. And all the values of x from that root this way will produce a value for y that is greater than 0. But all the values of x that are in the middle here, those are going to produce values of y that are less than 0. So those will not solve this inequality. So the first thing I want to find out, though, is whether or not this quadratic expression has real roots. Does it actually cross the x-axis? So I'm going to find out if it has real roots by using the discriminant of the quadratic formula. So I'm going to use the discriminant b squared minus 4ac. So that gives me negative 6 squared minus 4 times 1 times 4. So that gives me 36 minus 16 equals 20. And since that is greater than 0, I know that I have two real roots. I also know that it is a parabola that opens upward because I have a positive leading coefficient. I don't have any negative sign there. So I'm not exactly sure where those roots are going to be, but I know that it's going to look something like this parabola right here, where it is going to open upward and is going to have two real roots. So I can tell that my solution is going to be from that real root that way and from that real root this way. Now, just so you know, if it wasn't a greater than sign, but it was a less than sign, then my answer would be in this area here, and the parts going that way would not be solutions. But that is not the case in this particular problem. So the first thing I'm going to do, so the next thing I'm going to do is I'm going to find out what my real roots are. All right, so I found my discriminant. I may as well continue using the quadratic formula to find out what my roots are. So I have negative b plus or minus the square root, well, I've calculated my discriminant is 20, the square root of 20, over 2a is 1, and negative b is negative 6, negative 6. So now I have my roots as 6 plus or minus the square root of 20 over 2. And I'm going to simplify that a little bit. I'm going to call that 6 plus or minus 2 square root of 5 over 2. And since all of the terms here can be divided by 2, I'm going to call this 3 plus or minus the square root of 5. So those are my two real roots. 3 plus the square root of 5 and 3 minus the square root of 5. So just to illustrate, I will put this on a number line. Really, I don't need to put it on a number line because I already know from my picture right here that this is going to be 3 minus the square root of 5 right there. And I know that this is going to be 3 plus the square root of 5 right there. And then my solutions are going to kind of go this way. So I could answer the problem right now, but let's just take it a little bit more slowly and put it on the number line. So here's a number line, and I've got my calculator, and I've entered in 3 divided by. I want 3 minus the square root of 5. And I get 0.76. So 1 point right here is 3 minus the square root of 5, about 0.76. And if I want to find 3 plus the square root of 5, that's about 5.23. Oh, so that's going to be even a little bit further out. That's going to be over here. This is 3 plus the square root of 5. Those are going to be my 2 zeros of this expression. And I don't really even need to know what the parabola looks like. I know it's going to come. I know that it's opening up. I know that it's going to have a vertex somewhere down here. I don't really care what the vertex is, because I know for a fact that the vertex has to be between the 2 roots. So the vertex isn't really important to describing the inequality. And since the inequality is asking me where is the expression greater than 0, well, that is from here, 3 minus the square root of 5 going that way, and 3 plus the square root of 5 going that way. And it is a strict inequality, which means that it does not include the roots, because the roots are at 0, they are not greater than 0. So I can either leave it as this diagram for right now, or I could write it in interval notation, and I could go negative infinity to 3 minus the square root of 5. And I want to unite that with the interval 3 plus the square root of 5 all the way to infinity. If I don't like interval notation, or I'm not comfortable with it, I can always say x is less than 3 minus the square root of 5, and x is greater than 3 plus the square root of 5. If it had been x squared minus 6x plus 4, x squared minus 6x plus 4 less than 0, I still would have had the same zeros. Would have been there and here. My graph still would have looked like that, but then my solution would have been right in here between those 2 points. So that would have looked like less than, would have bracket 3 minus the square root of 5, comma, 3 plus the square root of 5. It would have been that interval, that one interval between those 2 points. Or you could have said x greater than 3 minus the square root of 5, x less than 3 plus the square root of 5. But that wasn't the problem. The problem was this, where it is greater than. Did I write that properly down here? Yes, I did. Was greater than, and so that's how I got my solution.